Hey guys, the fifth lesson of chapter 13 is called Apply the Law of Sines. Now, the law of sines by itself, well, we're not going to sit here and define the thing because it's right in this box down below. But I just want you guys to know that you use the law of sines to solve a triangle. All right, when I say solve a triangle, what I'm saying is find all the sides and find all the angles. Now, this is really easy to do if it's a right triangle. If it's a right triangle, we can use our sine, cosine, tangent ratios, plug in the two sides we have, find the missing side, or any combination of those. But if it's not a right triangle, we're solving triangles without a right angle. And so we have to use this thing called the law of sines. Now, the law of sines by itself is a very easy formula. Basically what we're going to say with the law of sines is you can set up a proportion either of the following ways. If I make a ratio of the sine of an angle and its side opposite, so the sine of angle A and its side opposite, put those in a proportion. And that is going to be equal to the sine of angle B and its side opposite. All right? And finally, the sine of angle C and its side opposite would be like there. Now, when we solve, we're not going to be using all three of them. We'll just pick two of the three, and we'll show you an example of that in just a few minutes here. Now, they also go ahead and they tell you that you can do it the other way, like you can do this upside down too, so you can put all the side lengths on top, and you can put all the sines on the bottom, and it doesn't matter. And my point is it doesn't matter. So really, it's totally up to you guys whether you want to put the side lengths on top or the angles on the top, as long as you're putting the sine of A over the top of A, or vice versa. Again, A has to go with A. All right? Now, I'm going to give you a very important piece of advice for this lesson. Number one, the most important thing you can do is draw a picture. Now, example one is really easy. Example one is the easiest part of this lesson if you're given two angles. Now, they talk about this and they say it's a side angle side case or an angle side angle case. All that's saying is that the side is either included between the angles or it's not. And it doesn't matter. The bottom line is if you're given two angles in a triangle, you can always find the third one because you know that the angles in a triangle add up to 180. So if I do 180 minus 102 minus 28, that tells me the third angle is 50 degrees. So as I was saying before, the most important thing you can do here is draw a picture. Now angle B is an obtuse angle, so I'm going to start with that one, and I'm just going to draw something that I know is obtuse, which is 102 degrees, and that's side B right here, or that's angle B rather. All right, we're given that the side opposite of angle A is 8. So if I want to name this one up here to be angle A, then I know the side opposite of that, which is down here, is going to be 8. All right, this would be side B, this would be side C. Now, based on the other information given, this is angle A, this is angle B, and so therefore this is angle C. So this becomes side C and side B. And then from there, I'm going to plug in the rest of the information. I found that this was 50 degrees based on what I calculated here, and I was given that this is 28 degrees. All right, so now, in order to find, we've got all the angles done, we need to find the other two missing sides. So let's first start with saying, well, let's find side B. Side B happens to be the longest side in this triangle, and I know it is because it's opposite the biggest angle. So obviously the side opposite the largest angle is going to be the largest side. Again, if that proportion is true, then the side opposite the largest angle is always going to be the largest side. All right, so we're going to say then that B over the sine of 102, again, we put this is angle B. So side B over the sine of B equals side A over the sine of A. All right, so they just plug in the information there. Now, the way that I would do this then is I would use cross products. Okay, so I'm going to use cross products and go, okay, sine of 28 times B and 8 times the sine of 102. And so my math for this then would be B times the sine of 28 is equal to 8 times the sine of 102. From there, to solve for B, I would divide both sides by the sine of 28. And then these would cancel out, and I get B is equal to 8 times the sine of 102, all divided by the sine of 28. All right? Now, I'm going to clear that off the screen for you guys, and we're going to run over to the calculator now. Again, one of the things that you have to remember is when you're doing calculations involving finding angles, and these angles are in degrees, make sure your calculator is in degree mode. If it's not, you're going to go to your mode button, scroll down here, make sure you're in degrees. Okay, as long as you're in degrees, you may do this. All right, now the calculation that I need to type in here, again, was 8 times the sine of 102. And now I have to put this end parenthesis in here. I want to divide the whole thing by the sine of 28. All right, and that comes out to 16.668. So we're going to call this 16.7. All right. Now, to find the missing angles, or the missing side C, we would have to go back to my diagram, which I mistakenly erased. So this is now 16.7. Again, this was 50 degrees. This was angle C. We don't have that. This was A at 28 degrees, and this was 102, and that's B. Sorry about that. From there, then, we would set up a proportion, and obviously we have this angle, and we want this side. So we're going to say that C over the sine of 50 is equal to 8 over the sine of 28. And again, we know this side is 8. Now, you certainly can use 16.7 over the sine of 102, but 16.7 is a derived unit. We've calculated that. So maybe we made a mistake, and so we don't want the next step to be based on something that we made as a mistake. So maybe go back and use the original values. Again, totally doesn't matter, especially if you do it right. So this becomes C times the sine of 28. It's going to be equal to 8 times the sine of 50. And then we would divide both sides by the sine of 28. And I'm not going to take you over the calculator for this. If you guys want to type that in yourself, you would do 8 times the sine of 50. Don't forget that when the calculator brings up sine, it puts a parenthesis. So put the end one in, and then type divided by sine 28. All right, so you put this calculation in your calculator, and you end up getting that C is approximately 13.1. Now, it should stand to reason now, and it's really important that you guys understand that you need to check your work. It stands to reason then that the largest angle, angle B, should have the largest side opposite of it, okay? And side B happens to be 16.7, all right, which makes sense. Angle A was the smallest angle, and so angle A should have the smallest side opposite, again, 28 and 8. And then finally, angle C we determined to be 50 degrees, which is kind of in the middle, and our side length was 13.1. And again, 13.1 is between 8 and 16, and so that seems like we've done it correctly. All right, now, things get significantly more challenging in this lesson, okay? In the next page, when now all of a sudden, instead of being given 2 angles and a side, well, now you can't find that third side without doing a little bit of work. All right, so we're introduced to essentially 6 different cases, and this is really kind of confusing. But what I want to focus on first is this idea that if the angle that's given, again, this is side-side angles, they're only giving you one angle. If the given angle is obtuse, we can identify this with basically taking a look at 2 things. All right, now, we're going to do this, and remember what I told you before is always start with an angle. I always put my angle that's given in the lower left-hand corner, okay? And again, it's my personal preference. It doesn't matter how you do it, but I'm going to start in the bottom left-hand corner, and I'm going to draw a line out this way. And now I want to draw an angle based on the angle that's given, all right? Now, if A is an obtuse angle, it's going to kind of go out here like this someplace, okay? And so this is angle A. And again, it's totally irrelevant what A, B, and C are. In some of the cases down below, they're going to give you angle B, so you would just label your diagram differently, okay? Now, the side opposite of that is A. Now, we know that if this side right here happened to be B or C or whatever, all right, that if this is an obtuse angle, then side A would have to be longer than B because it's going to have to be the longest side. Again, we only have room for one obtuse angle in a triangle. So therefore, the side opposite of angle A should be the longest side. So what they're telling you in this first blank here is if A is less than B, then we can't make a triangle. We can't even make a triangle of that because if A is shorter than B, then I can't connect the dots and make a triangle because the side opposite the largest angle needs to be the longest side. And if it's not, then we can't even make a triangle. If it's bigger than B, then we can make one triangle. All right? Now again, that's if the given angle is obtuse. Let's evaluate the other 4 cases. And again, this is where things get a little bit confusing. If the given angle is an acute angle, this has to do a lot with the fact that when we use the law of sines, okay, we're going to end up taking the inverse sine. And we know that inverse sines, when I take the inverse sine of an angle, all right, these numbers ought to be positive. okay, because all the angles that we're dealing with are going to be between 0 and 180 degrees. We know that the sine values are the y values for all of these ordered pairs on the unit circle. We also know that when we take inverse sine, we get angles in the first and fourth quadrants. So in order to get a negative sine value, we would have to go down here someplace to get it. Again, remember, sines are y values. So if the sines are the y values and they're down here, well, that's going to mean that the angle had to be negative, and that's not going to fly if we're talking about a triangle. So in order for the angles to be positive, sines are going to be positive up in here someplace. Well, as you know, and as we've just talked about, okay, the inverse sine function would basically only then be able to give us angles in the first quadrant. Well, again, we're not talking about angle A here, we're talking about the other two angles in the triangle. When I start to set up my sine of A over A equals sine of B over B, right? We start setting those up. What happens if B is an obtuse angle? Okay? Well, our inverse sine function is only going to give us an answer in the first quadrant. So maybe, just maybe, we might have to find a reference angle in the second quadrant. And again, that's where all of this kind of gets a little bit more confusing. So the first thing I want to talk about is this. If A is acute, this is an acute angle, we're going to talk about this length h. And the length h says, okay, if I were to drop a line straight down and make a right triangle, all right, we would call this the height of that triangle. In this case, B would be the hypotenuse of that right triangle. And so the sine of angle A would be the opposite over the hypotenuse. Well, if I multiply both sides of that equation by B, you will then find out that the height of that triangle, that right triangle right there, is B times the sine of A. All right? So right here it says the height is equal to B times the sine of A. Now, this is, again, maybe a little bit conceptually challenging for us right now, but what we have to consider is we have to consider the fact that maybe, just maybe, the height of this thing, this length A, isn't even long enough to reach down to touch the bottom. So the first thing I do is I calculate, listen, if this is the given angle A, what is the height of this triangle? Okay, how far is it from the top to the bottom? And if I know that length, and the given side A isn't even long enough to reach that, then we can't even make a triangle. All right? If H is the exact same thing as A, then we make one triangle, and that triangle is a right triangle. Okay? If H is exactly the same as what the A length is given, then we know that this is exactly a right triangle. These are very rare. All right? Now, if the given side, okay, the given side A, maybe the given side A is long enough to reach. Well, now we have to examine two cases. What happens if angle B is an obtuse angle? Well, if angle B is an obtuse angle, then we'd get that triangle there. If we went the other direction and said, well, what if angle B was an obtuse angle? Okay, if I took the inverse sine and I got something here in the first quadrant, it is possible that maybe B is over here in the second quadrant as well. So I guess what I'm telling you is that we really have to draw a picture and consider each individual case. All right, and then finally in the last piece, if the given angle is A and the side opposite of A is longer than B, well, if A is longer than B, then we can only guarantee that there's one triangle here. All right? Now, I'm going to refer back to this chart later on, but to be quite honest with you, most of these examples are going to come from drawing a picture. So let's start with that. Let's start with a side-side angle case, and this is a side-side angle case because I get two sides and an angle. Okay? Now, given those two sides and an angle, let's draw a picture. First of all, they give us 94 degrees. I'm going to start then with an obtuse angle, something slightly bigger than 90 degrees. All right, and that's angle A, that's 94 degrees. All right, again, it's larger than a right triangle. So because this is an obtuse angle, because A is obtuse, we simply need to check and see if the side opposite of that, in this case 18, is 18 longer than the given side of 13. Well, if that's the case, then we should be just fine. Again, if 18 was shorter than 13, then I wouldn't even be able to make it all the way to C. Again, if this is the biggest angle, then this needs to be the biggest side. If it's not true, then we can't even make a triangle. All right? So this is an obtuse angle. The side opposite is 18. So now our picture seems to make sense. now all we have to do is start looking at setting up some proportions here, okay? So, again, it says since A is obtuse and that A is longer than C, only one triangle can be formed. All right? We'll use the law of sines first to find the angle C. Again, this is a capital C, so that's saying find side angle C. I have side C, I want angle C. I have side B, A rather, and I have side. I'm sorry, I have side A and I have angle A. I have side C and I want angle C. So let's start with that. The angle sine of C over its side length 13 is going to be equal to the sine of 94 over 18. Again, I'm just setting up a proportion of those quantities that are on opposite sides. From there, I cross multiply, and I get 18 times the sine of angle C is equal to 13 times the sine of 94. Now, when I take and I solve for C now, I need to get that sine of C by itself, so I'm going to divide both sides by 18, and I get that the sine of C is equal to 13 times the sine of 94, all divided by 18. All right? Now, according to my calculator, and I'm not going to get that back out right now, according to my calculator, that's 0.7205. All right? So I don't bother with any of this stuff. All I'm doing is using proportions and cross products. So if I know the sine of C is 0.7205, then I can take the inverse sine function of both sides and say, all right, then the inverse sine of 0.7205 is going to be equal to the measure of angle C, which we know to be 46.1 degrees. And again, I'd have to use the inverse sine function on my calculator to do that. All right? So to find angle B, this is then 180 degrees minus 46.1, and then minus the original angle given, which is 94 degrees. And altogether, we should end up with a 39.9 degree angle that's left over for angle B. So this is 39.9 degrees. This is 46.1 degrees. And now we just have to set up a proportion to solve for that missing side. All right? So to solve for that last missing side, which is side B down here, we would say the sine of B over 39.9 degrees is equal to the 18 over the sine of 94. And as I said before, use the two given pieces of information. I would not use C, angle C, to be 46.1 degrees, because if I made a mistake somewhere, then obviously that's going to be incorrect. Okay? Cross products again yields that B times the sine of 94 is equal to 18 times the sine of 39.9, and then I would divide both sides. In any case, I end up getting that B is equal to 11.6, and so once I get that B is equal to 11.6, this is 39.9 degrees. This is 46.1 degrees, and my last missing side is 11.6. Okay? All right, let's take a look at one more example before we try a couple of checkpoints here. I want to look at the top of the next page, and this one's kind of a cute example here, but let's take a look at this one. All right, it says solve triangle ABC with angle A to be 77 degrees. Now, again, they started with the picture for you. Pretend you didn't have that piece of information. I always start in the bottom left-hand corner. Now, I need to make something that's less than 90 because it's a 77 degree angle. So maybe something like that, okay? All right, so this is a 77 degree angle, and this is the given angle, angle A. Again, it doesn't matter which one's given. A, B's, and C's are completely irrelevant, but the given angle I always want to put in the bottom left-hand corner. The side opposite of that is 6.1, and then this side B, this other side B right here is given. Now again, you can start with this side over here, but it's a heck of a lot easier to think about this as a height, so we'll deal with that in just a moment here, okay? Now, we want to know, this is 6.1 right here, 6.1. And if this were long enough to come straight down, we'd make exactly a right triangle, all right? If it was long enough to go past it, then we'd be able to make two triangles, one where we swing it in here and one where we swing it out here, all right? But how do we know that it's even long enough to begin with, all right? How do we even know that it's long enough to begin with? Well, what we do then is we say, look, this H right here is the height of that triangle, all right? And so the sine of 77 is equal to opposite, this is an H, sorry, over the hypotenuse, where in this case the hypotenuse is given to be 9. So if I multiply both sides by 9, then the height of this triangle is 9 times the sine of 77 degrees. Now 9 times the sine of 77 degrees, I'm going to work that out right now, and 9 times the sine of 77 degrees comes out to 8.8. So that means that this length right here, if I went straight from this point straight down, this is a length of 8.8. Well, look at the length here that I have for side A. Side A isn't long enough to cover that entire distance. If I bring side A straight down here, 6.1 units, it's not even long enough to get to the bottom to make to even make a triangle. Because according to this calculation here, the height of this triangle has to at least be 8.8. Sorry, it has to be exactly 8.8. And so the height here isn't long enough. Okay, there's no way I can swing this down far enough to make it catch down here. And so for that reason, there are no triangles that I can even draw with this. This information leads to a no triangle concept. All right? Now, there's a couple checkpoint problems in the text. What I want to do is I want to get all the notes to you. So I want you guys to finish the notes. We're going to save these examples, and we'll do them in class tomorrow. All right? In addition to that, this example 4 is very difficult to squeeze in to a video. All right? And the reason for that is because this is one of them that's going to require us to make 2 cases. Now, if you want to look back at that text box and you want to go back and look at the 6 cases, back on page 340 in your note-taking guide, feel free to do that, all right? However, if this makes no sense to you right now, let's hold off on that example, because as you can see, that's quite a lengthy example, and let's finish the lesson, okay? On the last page of the lesson, we get into this other idea that comes from using a formula to find the area of a triangle. Now, as you know, the area of a triangle is base times height divided by 2. Well, base times height divided by 2 is not going to work for us because it has to be a right triangle to do that. The area of any triangle formula we can use, the area then is going to be 1/2 of the lengths of the 2 sides and the sine of the included angle. All right, so I know this is very complicated here, but basically what we're saying is if I'm given angle A and I'm given these 2 sides right here, I can find the area by taking 1/2 of the products of the 2 missing or the 2 given sides and the sine of the included angle. Again, the angle has to be between those 2 sides if I want to use this formula. So in addition to that, we could say 1/2 A times C times the sine of angle B. Or we could say 1/2, which one haven't I used? B times C, the sine of angle A. All right, so any of those combinations would work. Whoops, I already had that one. 1/2, I got AB, no, I didn't only have AB. AB times the sine of C. Sorry about that. So all 3 of these formulas basically say the exact same thing. We take the product of the 2 sides given, the sine of the included angle, and take half of it, and that finds the area of the triangle. All right, so let's finish this guy up. Let's finish up this lesson. And let's look at an area example. It says find the area of a triangle. A piece of land is bordered by 3 roads as shown. Find the area of the land. Okay, well, we have this as 78 degrees. We have this as 2.3 and 1.4. So I have the 2 sides and the included angle. So this would simply be, and again, I don't care about A's, B's, and C's, whatever. It's 2.3 times 1.4 times the sine of the angle in between, which is 78.1 degrees. We would plug all of that into my graphing calculator, and it comes out to 1.6. And so the area of the land is about 1.6 square miles. Okay, because again, these are in miles, and so the units are going to be in miles. Try example number 5 in the checkpoints down below. You should be able to do example 5 in the checkpoints. The rest of it, like I said, example 4 we'll save as a wrap-up for what we're going to finish tomorrow. But go ahead and try example 5 in your checkpoints. The answer ends up being 6.3 square miles. All right, so if you want to work that one out, it should be 1/2 times the 2 sides given, 5 and 4.6, and then multiply that by the sine of, whoops, I'm sorry, it's 4.6 and 2.8. Sorry, I was looking at the 5 from example 5. So your 2 side lengths are 2.8 and 4.6, and then we multiply by the sine of 78.1, because that's the angle given in the previous example, and that should come out to 6.3 square miles. Okay, so that's going to wrap up lesson 13.5. I know there's a whole lot of holes in there that we didn't cover, but I just didn't feel comfortable trying to squeeze that into a video, so we will wrap that up tomorrow.